Hello guys, in this video I'll be covering linearly independent and solutions. If two or more equations are independent, then a general solution can be written as y equals c1, y1 plus c2, y2, assuming that these two equations are part of a solution to the same dE. So I'm going to go ahead and do this example problem. This example problem is from video 15, so just go ahead and explain it. So first start, I'm pretty sure this is also a homework problem. So the first step is then proving that these are solutions. So that prove like y1 and y2 are solutions to the dE. So y1 equals t squared, y1 prime equals 2t, y1 double prime equals equals 2. And the reason why I'm doing this is because I'm assuming that this y1 can be substituted in for the y in this equation given to us right here. And if I can plug this in and it equals 0, then that means it is a solution. So I'm plugging in y and y double prime. So then I will have 2t squared minus 2 times t squared. These cancel out, which equals 0. So it's a solution. Do the same thing with y2. So y2 equals 1 over t, y2 prime equals negative 1 over t squared, y double prime equals 2 over t cubed. So I'll plug this in, and I'll have t squared times y double prime, which is 2 over t cubed, minus 2 times 1 over t. And then this t squared we cancel out, so this comes to the first. Now I have 2 over t minus 2 over t, so these will cancel out, and now equals 0. So these are both solutions. Now I need to prove that these are independent of each other. So I can use Wronskian or the coefficient or the multiplier version. I like using Wronskian because it's a clear-cut method. So Wronskian for y1, y2 will equal y1, which is t squared. In the top left, bottom left will be 2t. Top right will be y2, which is 1 over t. Bottom right will be y2 prime, which is negative 1 over t squared. I'll be solving the determinant of this, so I'll multiply these two together. So I get negative 1 minus the product of these two. So now it'll become 2. This equals negative 3, which is not equal to 0, therefore linearly independent. So since they are solutions and they are linearly independent, I didn't even finish spelling out this. Independent. Alright, since these are both solutions are linearly independent, then I can make a general solution for it. So general solution will be y equal to c1 times y1, which is t squared, plus c2 times y2, which is 1 over t. And they give us some initial conditions, so we're able to solve for c1 and c2. So now we're assuming this, so now this is our new y that we're dealing with. That's what these initial conditions apply to. So y1 will equal negative 2, which equals c1 plus c2. Y prime of 1, actually I'm going to solve for y prime first. Y prime will equal to c1t plus minus c2 1 over t squared. Now y prime of 1 will equal 2c1 minus c2 equals negative 7. So now I have two equations, and I want to do systems of equations to solve for the c1, c2. So C1 plus C2 equals -2. That's our first equation. Our second equation is 2C1 minus C2 equals -7. These two cancel out when I add them up together. So our new equation will be 3C1 equals -9, which implies C1 equals -3. I'll plug this back into our first equation, 1. So I have -3 plus C2 equals -2, which implies C2 equals 1. So now I can plug this back into our general solution. So it would be y would equal -3 for our C1 times our t squared, which is our y1, plus C2, which is just 1, times our y2, which is 1 over t. So big thing to remember here is the equation for the general solution, which is, I'm going to write it out as y, oh, it's right here. y1 equal to c1 times, y equal to c1 y1 plus c2 y2 and so on. But in order for you to plug it into that, your solutions must be independent, and they must be solutions of the same DE. So that's it. If you have any questions or comments, leave them below. And if you have any criticism, also let me know. I want to know how I'm doing or how well I'm able to convey these ideas. And that'll be all. Good luck on your tests, and thank you for watching.